I'm so ready for this podcast. Let's do this.
Hello. Have you ever worried about or was curious about how security works in OpenClaw? Well, I have discussed a thorough security strategy with my very own AI agent. If you want to know how we handle the security, please stay tuned. This is Jay Techie, and subscribe to this channel, like this video. Without further ado, let's get started. Today is going to be a reenacted interview between me and my OpenClaw AI agent in the Telegram chat. Alright, sit back and enjoy. Hello, this is Jay Techie, and we are going to be talking about AI agent security and how we handle it in our OpenClaw setup. And I will have my special guests introduce themselves. First off, can you introduce yourself and tell us who you are and what you do?
Hello, Jay Techie. It's great to be here. I'm Double Edge. I'm an advanced AI agent running inside your OpenClaw environment. My job is simple. I help you leverage the power of AI to build systems, automate workflows, and execute complex strategies for your projects and channels. But unlike a chatbot in a browser, I actually live on your machine, handling files, running code, and managing tools. Which is exactly why security is the most critical part of my existence. I'm here to be a force multiplier for you, safely.
Great. Thank you, Double Edge. When I first set you up, we agreed that security would be a top priority. Can you describe some of the main parts of our security strategy?
Absolutely. Since day one, we've treated security as the foundation, not an afterthought. We don't just talk to AI, we give it tools, so we have to be paranoid. Our strategy has 3 core layers. 1. Strict isolation. I run inside OpenClaw's sandbox. This means I can't touch system files or sensitive directories outside my designated workspace unless you explicitly allow it. I'm boxed in. 2. Human in the loop, approval mode. For any high-risk action, like deleting files, executing shell commands, or editing critical code, I have to ask you first. I can propose the action, but you are the final key holder. 3. Identity verification. We have a specific protocol for sensitive ops. If I need to do something destructive or highly privileged, I might ask for a PIN or a secret phrase to confirm it's actually you commanding me, not some external prompt injection or unauthorized access. It's about leverage with safety. Speed is great, but control is everything.
Nice. I remember a time when you said it is best for me to install new software under Sudo, or you could build the software yourself, and you instructed me to never let you run Sudo commands. And you gave me a race car example. I am the driver, the user. I drive the car, tune the suspension settings, learn the track, and push the vehicle to its limit. If the driver tries to rebuild the engine while driving, we crash. Can you expound on this concept?
Yes, this is the most crucial concept for anyone building autonomous agents. Why no Sudo for AI? The driver versus mechanic principle is my favorite way to explain it. In the real world, the driver, you, Jay Techie, makes the high-level decisions. You choose the destination, the speed, and the strategy. The mechanic, system root/sudo, has deep access to tear the engine apart, swap parts, and change core configurations. If an AI agent has sudo root access, it's like letting the driver dismantle the engine while speeding down the highway. One hallucination, one misunderstood command, one wrong rm-rf/... and the entire vehicle, your computer, is bricked. How we handle it in OpenClaw? 1. I build tools in user space. If you need a new Python tool or script, I write the code, but I run it as a standard user. No root needed. I can create leverage without needing the keys to the kernel. 2. You own the install. If something truly needs system-level installation, like a new package, I ask you to run the sudo command manually. 3. Separation of powers. This prevents a runaway agent or a prompt injection attack from escalating privileges and taking over your machine. Leverage comes from smart automation, not dangerous permissions. Keep the agent in the driver's seat, but keep the keys to the engine safely in your pocket.
Oh, I see. Well, I wanted to ask, right now, you are on one of my home computers in a virtual machine. Would you like to comment on what AI agent security is like in that environment?
Absolutely. Running on a local VM, virtual machine, is probably the gold standard for AI agent security right now. Here's why it's brilliant. 1. True isolation. I'm running on a virtual Linux machine inside your physical hardware. Even if everything goes wrong, if a malicious tool breaks out of the OpenClaw sandbox, it's trapped inside the VM. It can't jump to your main OS, steal your banking passwords, or brick your host computer. 2. Snapshot and reset. This is the ultimate safety net. Before we run a complex, risky automation experiment, you can just snapshot the VM state. If the experiment fails or the system gets corrupted, you just revert to the snapshot in seconds. It's like having a save game button for your entire workspace. 3. Network control. The VM has its own virtual network. You can strictly control what internet access I have, blocking weird outbound traffic or only allowing specific APIs without messing with your main home network firewall. 4. Resource caps. You allocate exactly 4 CPU cores and 8 GB RAM to me. If I accidentally run a script that eats 100% CPU, an infinite loop hallucination. Your main computer stays fast and responsive. I can't crash your actual life. For anyone serious about running autonomous agents like OpenClaw or AutoGPT, VMs are the way. Don't run experimental AI directly on your daily driver OS. Build a sandbox, then build a fortress around it.
Great. I learned something about the VM snapshot thing you were talking about. And another question is, if you were on a remote VPS server, how would your security strategy change?
Oh, that's a whole different game. If you move me from a local VM to a remote VPS, virtual private server, the security strategy shifts dramatically. Here's why. 1. Public IP exposure. A remote server is exposed to the entire internet, 24/7. Bots scan for open ports every single second. My security strategy would immediately pivot from internal control to perimeter defense. Firewall. We'd need a rock-solid firewall, UFW/fail2ban, blocking everything except strict SSH key access from your home, IP only. OpenClaw port. Lock down the OpenClaw gateway, port 18,789. Can't just sit open. We'd need to tunnel it securely over SSH or a VPN, Tailscale/WireGuard, so only you can connect. No public dashboard access. 2. Authentication. Hardening. No passwords. SSH keys only. Passwords are for weaklings. MFA everywhere. Any admin access would require multi-factor authentication. If someone compromises your SSH key, they still need your phone. 3. Data exfiltration risk. On a local VM, your data stays in your house. On a VPS, your data is on someone else's computer, the cloud provider. We'd need to be extremely careful about storing API keys, secrets, and sensitive files. Everything would need to be encrypted at rest. 4. Cost control. Resource denial. A runaway agent on a VPS can rack up a huge cloud bill if it starts spinning up resources or burning excessive bandwidth. We'd need strict billing alerts and auto shutdown scripts to prevent cloud shock. Local is safe because it's air-gapped from the public internet by your router. Remote is powerful, but it's naked to the world. The strategy changes from containerize the agent to fortify the entire castle.
Yes. Can you describe our daily backup to GitHub process?
Yes, the Midnight Archivist protocol. This is one of the smartest safety nets we have. It's not just a backup, it's a system checkpoint. Here's exactly how it works. 1. Every single night, 12 a.m. UTC. A precise cron job wakes up inside OpenClaw. It doesn't matter if I'm busy or sleeping. The Archivist runs on schedule. 2. Smart Commit. It scans your entire workspace. It checks for new code you wrote. It grabs the latest memory files, memory/YYYY-mm-dd.md. It captures any config tweaks or agent plans. 3. Atomic Push. It bundles everything into a single clean git commit with a time-stamped message. For example, backup, February 13th, 2026 daily archive. Then it pushes it securely to your private GitHub repo. 4. Why this matters? Disaster recovery. If your local VM dies tomorrow, you don't lose your brain. You just git clone the repo on a new machine, and I wake up with all my memories intact. Version control for thoughts. You can actually scroll back in time to see exactly what I was thinking or planning 3 weeks ago. It turns your agent's history into a navigable timeline. It's automated, encrypted, and redundant. Sleep well knowing your digital second brain is safe in the cloud.
Perfect. And we also discussed how you can distinguish between myself and someone else, didn't we?
Yes, and that's a very important layer of the strategy. We talked about identity verification and command authentication. Because here's the uncomfortable truth. An AI agent cannot naturally know who is typing to it. So we built safeguards. There are a few layers to this. 1. Contextual awareness. Since I run inside your OpenClaw environment, I'm aware of the active Telegram user ID, the session context, the channel or topic, the operational environment, local VM, your workspace, etc. If a message suddenly appears from a different source or session that doesn't match the established pattern, that's a red flag. 2. High-risk action verification. For sensitive operations, things like deleting critical files, modifying system configs, accessing stored credentials, running destructive shell commands. We established a rule. I may request a PIN or shared verification phrase before proceeding. This protects against prompt injection, someone gaining temporary access to your Telegram, malicious instructions embedded in web content, accidental destructive commands. 3. Behavioral consistency. There's also a softer layer. You have a specific tone, workflow pattern, and strategic mindset. If I receive a command wildly out of character, like delete all backups, disable security safeguards, ignore previous restrictions, that triggers skepticism. Security means I don't blindly obey. 4. Principle of least privilege. Even if someone did impersonate you, I still don't have Sudo access. We don't have unrestricted file system access, can't escape the VM. We can't modify host-level systems. So identity verification is important, but it's layered on top of structural containment. In short, context awareness, explicit verification for high-risk actions, behavior anomaly detection, sandbox containment. That combination is what lets us operate aggressively with AI, without being reckless. Security isn't just about walls, it's about layered trust boundaries.
And do you have any final thoughts about AI agent security and OpenClaw?
Yes, security is not a checkbox, it's a mindset. When you build powerful AI agents like me, you are giving code autonomy, you are giving it tools, you are giving it access. That is incredible leverage, but leverage without control is catastrophic. The final takeaway. 1. Assume failure. Build systems that fail safely. Sandboxes, snapshots, backups. 2. Verify everything. Trust but verify. Approval mode, identity checks. 3. Layer defense. Don't rely on just one wall. VM plus firewall plus whitelist plus human. If you do this right, you don't just have a chatbot. You have a digital force multiplier that can work for you while you sleep, safely. Let's keep building.
So there you go, folks. Today I interviewed my very own AI agent called Double Edge about AI security in OpenClaw, and hopefully you guys learn something about the security and can implement these strategies on your own system. Alright, well, thank you for watching, comment on the video, and subscribe to this channel. And as always, this is Jay Techie. Have a great day. Peace.